In this question we are going to find out the current I of t at t is equal to 0.5 seconds as indicated. I of t, it is indicated over here. Okay. So we are going to calculate current I of t at t is equal to 0.5 seconds, and given that one switch was open for a long time and it is closed at t is equal to 0. Okay. So before t is equal to 0 we are going with for t less than 0 switch was open. Switch was open for a long time. When the switch was open for a long time, okay, this consisting of only this branch will not be present. So this switch branch is not present. Remember that one. Okay, so it consisting of only 3 branches, that is 10 amperes is flowing into 5 ohms and 5 ohms. And for a long time the inductor reaches a steady state. Okay, inductor L acts as short circuit. Okay, so under steady state inductor acts as short circuit since the switch was open for a long time. So replace the inductor with a short circuit with removal of this switch branch. Then the equivalent circuit is looking like this way. A 10 ampere source that is flowing into 5 ohms as well as one more 5 ohms with short circuit of inductor. So this is 5 ohms, this is 5 ohms, and current flowing through the inductor, say current flowing through the inductor is IL of t. So IL of t, that means 0 minus IL of 0 minus, that is at the time of just before the closing the switch. IL of 0 minus, by that time inductor has reached the steady state and it is acting as short circuit, and IL of 0 minus, using current division rule we can say it as 5 divided by 5 plus 5 into 10. So IL of 0 minus is 5 amperes. Now the current flowing through this inductor IL of 0 minus is equal to 5 amperes. Okay. Now for t greater than or equal to 0, second case, for t greater than or equal to 0 switch is closed. Switch is closed. When the switch is closed it is acting as short circuit. So this one is present now. This one is present. So the line is present. When the line is present, that means short circuit is present. Okay, and current coming from this one is I of t. The current going into this one is IL of t, and this current is 10 amperes. Remember that one, since it is a short circuit, okay, the current flowing through this 5 ohms is neglected because this is a resistor whereas it is short circuit. So current always flows into short circuit, no current is flows into this 5 ohms. So current flowing into this one is 0 amperes. So no need to consider this 5 ohms. And now apply KCL at this node. Apply KCL at this node at t is equal to 0 plus KCL at node. So incoming currents are positive, outgoing currents are negative. So because of that one, 10 minus I of t, current flowing into this switch, and current flowing into inductor side is IL of 0 plus is equal to 0. For t greater than 0, for t greater than 0, the same equation KCL can be written as 10 minus I of t minus IL of t is equal to 0, where IL of t is, IL of t means current flowing through inductor gets discharged and discharging current is specified in this way. Okay, IL of 0 plus into e power minus t by tau, where tau is equal to L by R. L means 2.5 Henry, R means 5 ohms, because this is a circuit. Okay, this is the circuit which is relating with RL and along with a short circuit. So only the components of R and L should be covered in this loop. Okay, so L by R, you can write it as L means 2.5 Henry divided by R means 5 ohms. So tau can be written as 0.5 seconds. 0.5 seconds. So the general equation will become now 10 minus I of t minus IL of 0 plus. IL of 0 plus is equal to IL of 0 minus. Remember that one. Current flowing through inductor doesn't change instantaneously. So even though the switch is changed at t is equal to 0, but the current flowing through inductor doesn't change. So IL of 0 minus is equal to IL of 0 plus. IL of 0 plus is 5 amperes. So this is 5 into e power minus t by tau. Tau means 0.5 is equal to 0. So general current equation I of t is equal to 10 minus 5 into e power minus 2t. This is for t greater than or equal to 0. Okay. Now you are going to calculate at t is equal to 0.5 seconds. What is the value of I of t? I of t at 0.5 seconds is equal to 10 minus 5 into minus 2 into 0.5 seconds. Okay, that means 10 minus 5 into e power minus 1, which is equal to 8.16 amperes. So the right answer for this question is 8.16 amperes. 8.16 amperes. The only one important point you should remember for this calculation is the current flowing through inductor is discharges to 0, because when the switch is closed, no source is supplied current for the RL branch, and whatever the current it has stored, that has to discharge. While discharging, current flowing through the inductor can be written as I naught into e power minus t by tau. The general equation is I naught into e power minus t by tau. I naught is the current which is stored by the inductor at t is equal to 0. That is what 5 amperes, which already we calculated. So you have written this equation. Then you can calculate at any point of time. Right answer for this question at t is equal to 0.5 seconds is 8.16 amperes. Thank you.